Ask someone to picture military power, and they usually think of a main battle tank. These 70-ton machines are built for dense armor and firepower. But a lone tank faces immediate limitations. It cannot see over the horizon, is easily blocked by deep water, and eventually runs out of fuel. To function effectively, modern armed forces rely on a vast, interconnected ecosystem of specialized machines, each engineered for a distinct task. The strength of a modern military lies in this diverse network, with each vehicle solving a specific operational problem that the others cannot. At the front lines, the main battle tank represents a specific engineering trade-off: heavy protection and tracks for cross-country mobility, combined with a large rotating turret for direct fire. This interior breakdown shows how a tank's volume is dedicated to the turret ring and ammunition. To move soldiers safely, armies use armored personnel carriers. These APCs use that internal space for a passenger cabin and rear ramps, serving as protected transport for infantry. The infantry fighting vehicle sits between these two designs. It retains space for a small squad while adding a medium-caliber turret and advanced sensors, allowing it to support those troops once they reach the objective. Frontline operations rely on this spectrum of armor, balancing the need for direct fire lethality with the requirement to transport people safely through hazardous terrain. Before the heavy armor moves, reconnaissance vehicles scout the path. These machines trade thick plating for speed, utilizing sensor masts and long-range antennas to gather intelligence on what lies ahead. For targets beyond the horizon, militaries deploy self-propelled artillery. While they look like tanks, they are engineered for long-range support, using heavy-caliber guns to hit distant targets from a position of relative safety. When an army needs to saturate a wider area, multiple rocket launcher vehicles provide massed fire support. These platforms carry launcher pods on mobile truck or tracked chassis to deliver high volumes of fire over vast distances. Looking at this blueprint of an air defense vehicle, the focus shifts toward the sky. Instead of a ground-facing gun, this platform is defined by rotating radar emitters and vertical missile tubes designed to protect the unit from aerial threats. Heavy armor is vulnerable without this dedicated network providing the advance warning and the long-range protective fire necessary to keep the force moving. The entire fleet stops moving without military logistics vehicles. Cargo trucks and fuel tankers act as the essential lifelines, constantly shuttling fuel, food, and ammunition to the forward units. When the terrain becomes an obstacle, combat engineering vehicles clear the way. These heavy machines use dozer blades and folding mechanical bridges to bridge gaps and remove barriers that would stop a standard vehicle. If a machine breaks down or gets stuck, armored recovery vehicles move in. These heavy-duty tow trucks use cranes and high-capacity winches to rescue and repair disabled hardware under armor. As this chart illustrates, a tank's operational time is finite. Its ability to stay in the field depends on these logistics and engineering lines. Without this mechanical backbone, even the most advanced combat vehicles eventually stop functioning. Geography presents barriers like rivers or coastal zones. Amphibious vehicles use boat-like hulls to move directly from land into deep water without losing momentum. Coordinating thousands of moving parts require command and control vehicles. These act as mobile headquarters, using satellite dishes and map screens to process information and direct units from the field. For rapid patrols and light transport, armies use light tactical vehicles. These off-road 4x4s prioritize speed and agility over protection, allowing for flexible movement across rough terrain. In extreme conditions, specialized terrain vehicles take over. They use specific adaptations, such as ultra-wide tracks for snow or specialized cooling for desert heat, to operate where standard vehicles cannot. These specialized designs allow a military to manage the sheer friction of coordinating thousands of troops across difficult environments. The next evolution involves removing the crew entirely. Unmanned ground vehicles are robotic platforms equipped with sensors and cameras, built to handle high-risk scouting or hazardous tasks remotely. Eliminating the need for a human driver allows these platforms to operate in high-threat environments that would be too dangerous for manned vehicles. When we map these roles together, the interdependency becomes clear. A tank relies on a logistics truck for the fuel required to stay mobile. That logistics truck requires protection from an air defense unit. The air defense unit follows orders from a command vehicle, while reconnaissance teams identify the targets for the artillery to hit. This integrated fleet creates military power through specialization. every machine performs a specific task that the others cannot, ensuring the entire system continues to function.